So I was playing around with a bit of, let's say, resource generation, and I thought that this was pretty interesting, and yeah, I thought to, do a video on it basically. So the approach that I've tried is by using the Poisson distribution, like it was suggested here. Now I've seen that there is also this Worley noise that we can maybe try to use, because this looks like it would be really similar to what we had, right, with those things. And it also looks like this diagram and also this thing, but I mean it's inverted, and yeah, it doesn't really matter because we can, invert it back. And I've seen that this noise RS library that I was using actually has this kind of, let's say, whirly noise, whatever it is, right? So, and I see that it's also related to Voronoi diagram and this distance thing, but I feel like probably starting with Poisson this distribution is a good idea, just to understand what's the idea behind terrain generation, like resource generation. So I have this little, the demo project that I've been working on. So let's try to understand how this thing works, and I mean, we can go to the drawing board to do that. So as I guess as you can see here, we have our initial map, right, and then we add stuff on top of it. Now sure, we can try to just randomly plop points, but they would be in random positions. So if you look at these points, they kind of look not that random in some weird way. Like they are random, but they are at like almost equal distances to each other, right? I mean, it's not really equal distances, but like close to being equal. So how can we do that? I mean, this Worley thing doesn't really look that similar, but if it's easier to implement, then I would go with this. Honestly, I think I'm after the shader phase, I think it's more important to be easy to implement rather than efficient in the demo stage of this project. Like, I feel like if we need more performance, we can do it later, but it should be simpler at first. So yeah, let's try to see how it works. So let's imagine that this is the entire map, or I guess let's draw our map first. Yeah, let's say this is the map, right? It's not perfectly square. Anyway, right, and maybe this is a bit of a spoiler, right? We see that we split it into grids. Like, I wish there was an easier way to do grids in GIMP, but I mean, we can enable grid, but it's not the same thing. Anyway, we'll do it like this. So yeah, like we gridded our map, right? And if we try to do like random, it would be maybe, let me increase the size, would be like this, like random points all over the place. Wouldn't really be like, you would have resources next to each other, would be really meh in a way. But with this approach, how it's gonna work is in the following way. So let's say we choose a random point somewhere on the entire map. So let's say it's somewhere here, right? I guess, I mean, first let's talk about the radius thing, right? So imagine that we choose a point right on this edge, like right in this corner, right? If we take this as a radius and draw a circle around, let me just, well, let's hope that I draw a good circle, I guess. The circle would be something like this, right? Jesus Christ, the circle is so bad, but you get the point. It's like these are all the, like this is the radius, right? So regardless of like if we choose another point, it's easy to find out if it's inside of this influence radius, right? And the other interesting thing about this is that if the point is right on the edge, it can affect this part, this, you know, only these squares, right, on a radius of 2 at the most. So this would be one idea. The other one is using, the Pythagorean Jesus, I have like a stroke right now with the Pythagorean theorem. The a squared plus b squared. Jesus. Pythagorean, the formula, which gives us, let's say we have a radius and we want to find the length of this thing. Well, hopefully it's pretty obvious that it's gonna be radius divided by square root of 2, right? I mean, if it's not, then try to use the formula, but I guess, we'll have a radius as input to our function. This is one important thing. We'll also have the size of our map, because we need that, since we say that the noise map has a size of 32, I think. Where is it? Usually we'll use 32 as the size of our map, so I think that's somewhere here. With height, whatever. I think this, yeah. I mean, in our main game we have more stuff than that. Like, this is just an example. So, as I said, we have the radius as input, the size, which is gonna be 32, and we also have this k parameter, which is described here what it does, but we'll get there. So it's called like rejection constant. So if we fail to find a point in less than k steps, then that point is trash, we throw it away, so we don't care about it. But as you can see here, we compute the cell size as I showed you here. It's radius divided by square root of 2. Then we get the grid size in cells. So we pass 32, right? But in fact we have like 1, 2, 3, 4, like an int number of squares. So again, I mean, we are familiar with this stuff because we did chunks for our terrain generation, so it shouldn't feel that weird to do this thing again. But this time we split our chunks into smaller chunks called cells, so it is what it is. Then we have this grid mapping, which is used for, let's say, caching our results, because we can do it without this grid, but since this algorithm runs in O(n), I think it says here O(n), since it's iterating over like a matrix, usually that would be n squared, but because we use this grid hashing, which I guess cache, I guess it's more useful in the validation check, because instead of looking, because let's say we choose a point somewhere here. To check if it's valid, you would have to look at the entire grid, but because of this constraint of having this radius, which affects only these 4 squares here, these 4 here, these 4 and these 4, we have to look only at these, right? So it's a constant amount of squares that we have to check, and that is gonna keep it open basically. So that's a good thing. Then we have our return value, which is gonna be samples. I mean, I've tried a bit to make it more rusty, but I feel like just following step by step the algorithm is easier. The formatting of the code shouldn't be that big of a deal. Then we have the active array, which, as said here, is gonna keep I guess the active list is kind of also similar to samples, but it's also gonna at some point it's gonna be equal to samples, but it's more like the visited in search algorithms. So we are gonna actually more like the queue in DFS, BFS. We add stuff to it and then we remove it once it's done, and samples is more like visited. Yeah, anyway, then we need like a uniform sampler, so I just created one here. I just wanted to have like a seedable sampler, so like if we run it multiple times, we'll get the same resources with the same seed, so it's gonna be the same map, right? That's something that I kind of want to have, like being able to replicate a map, because otherwise it kind of sucks. Like in Minecraft you have if you use the same seed, it's gonna be exactly the same map, right? It's not gonna have anything change. Maybe how mobs move around and stuff, that's gonna be different, but other than that it's gonna be the same exact map. So that's why I wanted this uniform sampler here, created from a seed. And then we choose our initial point, which in this algorithm it says that choose a random point, right? So we pick I think here it says choose a random point, doesn't matter, right? We insert that, so initially we compute its coordinates, so this is the coordinates on y, coordinates on x, and we get the index in the grid, right? And we say, okay, at these coordinates we have this point, and the convention is to use the index inside of the grid, and that's because of the caching, so it's gonna be easier for us to cache stuff if we keep integers inside of this grid. Then we say that this initial point is gonna be in the result, obviously it's the first point, and we also add it in this queue. And then, as per usual, as long as we have points in the queue, we have to iterate, right? So again, we choose a random point. Like, I guess we choose a random point from our queue, and we do not pop it yet, we just select it. And if we cannot find any neighbors for this point, we say, okay, that point is completely useless, we remove it because we couldn't find any neighbors for it, so we might as well just not have to try again with it, because if we couldn't find one, then just choose another point. you know. So that's the idea with this. I mean, I don't know, I would say it resembles a bit BFS in a way, because we choose the point, we explore all of its possible neighbors, and then we remove it. But in this case it's like BFS, but instead of exploring all the possible neighbors, we explore a subset of the neighbors. Like if we had used BFS for this, it would look like a grid, exactly like a grid. So this adds a bit of randomness to that grid, right? So like BFS would just find, okay, you had a point here, you have a neighbor here, a neighbor like here, a neighbor, another one here, like it would be exactly like a grid. So this algorithm adds a bit of randomness with skipping some of the neighbors. Right, so I think that's a pretty nice project. If you think about it, it's just BFS but with a bit of randomness, right? And that randomness is given by this this thing right here. So I found it really funny. It says annulus. Yeah, you have to, so we have the point, right? Let's say this is our point, and we have to look in a random direction to choose the next point. So how can we do that? Well, we have the radius, which is this amount, and we also have 2 times radius, which is this amount, right? And we want to choose a point like between these two values right here, between radius and radius times 2. And what's interesting is that that value can be anywhere on this like donut shape thing. So I mean, it's not to scale, it should be, you know, a bit, I mean, I think it's fine. Yeah, it should be somewhere around this donut shaped thing, right? That's where our candidate point is gonna be. So, you know, we take it, then we check if it's valid. We'll see how we do that. And I mean, if it's valid, we have to add it in our result, also in the queue. So later on we can take this one and find its neighbors using the donut shape. So, you know, makes sense. And I guess we also add it to the grid. So we have these 3 kind of arrays. We have the grid, samples, and active, which we have to keep in sync with each other. So I guess, you know, it makes sense. Now how does isValid works is first of all we check if the candidate is inside of the bounds. So, you know, that's one thing we have to check. And then you know, we take the coordinates, like in which cell does this point exist, so like this. And as I said, instead of checking all of the entire grid with for validity, we only have to check this this range right here, right? So 2 cells to the left, 2 cells to the right, and the same thing up and down. So that's what we do here. We subtract 2 and we add 2. So that's the range that we have to check, right? So, you know, we try to find something from the grid in this range right here, and if we find anything, then we want the distance between these 2 points to be smaller than radius. So as if they don't intersect with each other. Like, you know, we can have a point here and another point here, but that's just because the radius, like the distance between them, is greater than the radius. So, you know, it's fine. That's when these points are valid. So I guess that's everything for this disk distribution thing. I guess it's, you know, not that complicated, honestly. So, but what would be more interesting is actually adding some rules for which ones to keep. And even more interesting, I would say, would be, because yeah, sure, we can keep, like, let's say these are rocks, and we can keep them when we have noise larger than you know, 0.2 or whatever it is for hills. So we keep them in this place, and everywhere else they are not gonna be there. But I feel like it would be more interesting to try this approach of converting our thing into some kind of a noise map, right? And afterwards to try to replicate this. But as I said, I feel like for that would be much more interesting to use the Worley noise thing. So, you know, I guess now that we understand how, like, the main idea of this thing works, I guess we can switch to that and try to get this working like this. Because, you know, generating the noise map of this distribution could be interesting. You know, I might say it would be interesting, why not? But I feel like this would be easier, and, you know, why not just try this one? I really like how this thing looks like a diagram, right? But again, we can try out this kind of stuff. So, for example, I mean, you can even see it, like, this is Manhattan distance. Where is it? Manhattan distance looks more squarish, and Euclidean distance looks like more circle-ish, if you know what I mean. So like, I would probably try to use this thing and do the thing from here. So why not? Let's try to do that. Okay, so I mean, for that thing, so let's just see again this really cool stuff. Like, now this thing would have circles around them, right? So we could do that, but you know, I feel like using the already implemented Worley noise would be more like easier for the demo, and we can also see if it's gonna make sense. So let's do resources noise, right? So let's just remove all of the stuff that's related to Poisson disk sampling. So we are not gonna use this thing, right? Let's see if it compiles. 06, right? We have some unused things, but that's all right. Okay, so we have the map. Perfect. So this is the noise map, but we can try to go into the Worley example, and I think I want to use for the Euclidean squared, probably. Like it looks I mean, you know, just the example, but squared. I'm curious what squared means. So we have this squared Euclidean squared value, right? What's oh, so it's just distance function. Okay, so now let's just try this thing. It's also permutation table, which is, what is that? But let's copy paste this part. So now the image is gonna stay, right? So just let's have a hasher, whatever that means, right? Oh my god. Okay, we don't use random, so let's just remove that. Dude, come on. Yeah, right, it's so weird. Or something broke with the LSP, obviously that happened. It always does. Anyway, isn't there like Worley as a thing here? Because I mean, I don't know. Like it is, right? But, and we can pass it the distance function, return type, frequency, seed and stuff, so that's why I wanted it like this, right? So because we can do, I don't know if we can do this kind of stuff. Let me check. No, it's just like this. Pretty ugly, am I right? So I mean, we still need the permutation table, I would assume, but can we do FBM again? Would this work? Okay, I'm curious how this thing works. So it has a new function. Okay, I mean, we can change stuff, which is neat. It has a seedable and shit, so okay, I mean, let's see. let's create a new Worley, right? So man, this distance function, it has this noise function, right? So that's what we can use in a plane map builder. So let resource map is gonna be plane map builder, new Worley, like this. Set size is gonna be, hopefully it's still 256 by 256, and the bounds, right, just to have replicability, let's call it. So we don't need any of that, but I would like to display this resource map to see how it looks. Resource map, and let's just use, let's see what happens if we try out this thing. So it's gonna be completely white. I guess the zoom is too big. No, we can say something like, whoopsie doopsie, let's say -10 10. See what we get. I'm curious what this is gonna look like. No, sure, I shouldn't use, you know, gradient for. Okay, I mean, it looks pretty fun, to be honest. You know, like we can make out these are resources and stuff, you know, but it's not enough for my thing, because I would like Euclidean squared. I mean, interesting. It called, okay, so maybe it's like Euclidean squared, right? But how would this thing work? Right, it doesn't have a 4D inside of this thing, so oh, it actually has something. Okay. Okay. 06. So we can say maybe, damn it, where is it? Plane map builder. We can give it the dimensionality. So let's say we give it 4 here, right? But I don't know how to. What the hell is source module? Fuck. So it's nice function. How can we tell it it's gonna be 4D? Right, that's interesting. fuck? Is it like this? I mean, it's right. Bruh, how do you say it's four-dimensional? I guess if we pass in 40 points somehow. Oh, like dude, come on. Right? How can we say it's 4D? Jesus. Like surely. Ugh. Ugh. Exactly. I have no idea. Let's leave it like this. Fuck that. Let's say with the fuck. I thought isn't here like set distance function, right? Am I crazy? Takes in a self and returns. Yeah, it should be set distance function, and we should say something like Euclidean squared, right? Distance function Euclidean squared. So what do we get now? Still ugly as shit. So this would be because of 2D, but it's 2D Euclidean squared, right? And here it says, oh, distance. Set return type, and that should be return type distance. Alright, so we have to return the distance, it seems. It seems like we want distance. Fair enough. And yeah, I mean, it looks a bit more like how it should look like, but again, like color gradient, I would like grayscale gradient just to be able to see something. I mean, yeah, it looks like the thing from Wikipedia. So can we go back to this bounds? And again, I would be curious how we can set the dimensionality of the thing, because no idea how you do that. So yeah, thing is, this is really small, so maybe let's try to set frequency. What frequency do we have by default? 1. So let's say 10. right, 10.0, and I wanted to do something like that. Let's say we increase the frequency so we have more stuff on the thing, right? So now we have this kind of stuff. I mean, it looks interesting, although too much influence, I would say, but it is pretty much this but inverted. So as this guy said here, I mean, it didn't say that, but now we can do 1 minus. I'm curious. So this is how you do it. So it's exactly distance. So how would we be able to invert it? So that means, so yeah, like what happens here is we choose a point somewhere random, and it says that, you know, obviously distance from here to here it's really small, but how the longer you go, the higher the distance, so it becomes more white. Right, that's the point of that. So I was thinking inverting it somehow, but not sure how exactly. But it doesn't matter because here it says invert the noise. Huh. I mean, it's not the same thing. We have to invert both of them, funnily enough, and you know, divide by the influence layer. So that's interesting. Well. Let's try to do that thing, but on the Worley itself. So resource map dot iter mute. And so we try to get this formula. So we iterate mutably the data itself, and we should do a for each. But before that, we have to zip with noise map dot iter, and then we can do for each. And here we have I, which is from resource map. So let's say R and N. I think this should be mutable, this shouldn't be. Okay, that's good. So I mean, let's define it as mutable. So we have to do 1 minus. Okay, so it's gonna be R is gonna be 1 minus, and on the denominator we have 1 minus N. Makes sense. Let's do 1.0, and on the denominator we should have R, but since R is inverted, we have to also do 1 minus R, right? So do I need to dereference it? Just there. Okay, perfect. So let's see if this actually changes anything. Like, it should be now it sucks. what if we just invert it? Let's try to invert it only. So it should be, damn it. So it might mean that since we return the distance, it's not normalized, right? So how can we actually normalize it? So build grayscale gradient. Right, I guess that's what it means. So can we find let maximum is gonna be resource map dot iter dot max. Really? F64 doesn't have ORD? The fuck? How the fuck does it not have ORD? That's crazy. So this should be a function between two things, so A and B, and let's say A smaller than B, right? Or no? We should return ORD or what? Oh my god. Why the fuck doesn't it have ORD? Jesus. That's so weird. Anyway, like A's, I mean it's unsafe obviously, so can we have something like A smaller than B, and then we do ordering I just need to see less equal greater. Oh, so less else, I mean I guess it's because it should be, the fuck? No, but I guess I need curly braces for this thing, so this should be maximum. I'm curious, what is the value of maximum? Because I'm pretty sure it's not gonna be 1 because it's distance and it's not. Wow, it means I went. Yeah, I need to do the other way around. Probably the other way around. Ooh. Oh, that sucks. And if I don't do distance, that sucks. It's minus, so Worley is minus 1 1, or what? Or is all the noise from this library between minus 1 and 1? I don't get it. Because I was pretty sure the gradient. Oh my god, yeah, it's between minus 1 and 1. That's why this was like 0. Okay, yeah. Sure, okay. So we don't need a maximum. It's fine. But what we need to do, this is interesting. So I guess since this is between -1 and 1, we need to convert it. Okay, so let's go back to when we had the formula. I would say, well, you know, yeah, we had a formula. So to actually invert our thing, we just have to multiply by -1, right? So that's how we invert it, in fact. So this should invert the Worley thing, although yeah, it increases the strength because it does the inversion. Well, I guess that means, what if we just divide the two values? Oh, but we are gonna have division by 0. Whoops. Yeah. Damn it. Okay, so let's say something like let n01 is gonna be, so we have to add 1 and divide by 2, right? Pretty straightforward. N plus 1 divided by 2. This should do the job. Then for R01 we have to do the same thing. Then we do again R01 and say something like 1 minus N01 divided by 1 minus R01. So we also invert it, right? And to bring it back between -1 and 1, we have to multiply by 2. So is the inverse operation, right? Multiply by 2 and subtract 1. Let's see what this thing does. Ooh. Oh shit. Oh shit. I mean, strange. Following the exact same steps, like, bruh, why doesn't it work? Come on, I was tricked into thinking that it works. So the white here means like high, right? So like mountains. So if we also have these as white, it should subtract one another. Normalize your data. Okay, so I mean, it's fine if it's you know, values from 0 to 1, right? That's what we want. The fuck? It's not really working, man. I mean, let's think about it. Let's try to switch up the algorithm. So if we don't do this step, like let's just remove it to see again the Worley noise. Right, so we have these kind of values. Like, I'm wondering what math operation we can do noise map. I mean, I would show both of them, but I'm too lazy to do that, so... Oh, actually, I can do that, so... The fuck? This is the noise map. Do the what? The fuck, dude? I mean, I thought that the gradient worked. The fuck? Oh, I don't know. Damn it. So, yeah, it looks like the gradient is pretty weird. The grayscale gradient. For my world map. Like, all the values look the same. The fuck? I mean, you know, I can see some shades, but barely. Huh. Anyway, it doesn't matter. Question would be, what kind of math operations can we do? I don't know, we can try more stuff, like randomly try things, like for example multiplying the two values. Why not? Let's see what we get out. Huh. Yeah, it doesn't look bad, but in fact it does look bad. See that it looks a bit too small, like attenuation, like it doesn't look like it has enough amplitude. For some reason, I don't know why. But I mean, at least it's between -1 and 1, right? So at least we have that. But the values look so weird. Like when I do the grayscale gradient. So like in examples here. Like if we take a look at, I don't know, simplex Berlin 3D, doesn't really look like this, but maybe it's because of my scale here. So Let's increase the frequency. And let's use noise map, see how it looks like. Because yeah, like the gradient looks trash. I mean, now it looks better. Yeah. And resource map. So I would like to keep resource maps only if we are like so let's think about it, right? We have this kind of noise, right? This kind of noise, whatever it is, and we want to combine it with something that's inversed. So I mean, division would make sense, right, between the two somehow, because if we divide like a small number with a small number, we get small numbers. So we need a threshold also if we do the division. So for example, I mean, yeah, you know, this makes sense. This is not gonna be between 0 and 1, so r01 dot mean I guess mean 1 max 0, then we multiply by 2 and divide by and subtract 1. Maybe something like this. Right, I mean, doesn't looks like it's too much, honestly. Color burn, right? Yeah, so maybe another idea would be, let's try to see what happens if we have like R here, and instead of, you know, doing all of this on it, we do something like making all the values a bit smaller in some sense. But how can we achieve that? Like, is it enough to just subtract something from it? Feels a bit scummy to do that in some way. So let's say we have R0 between 0 and 1, right? And at the same time, we can say then We can try to divide it by 2 or something. This is gonna make it smaller. Then we have to multiply by 2 obviously and subtract 1. So let's see what this gives us. I would expect to see smaller influence on each resource patch, but it's not. That's strange. So if we do 1 minus all of this thing, is gonna invert it, right? So we are gonna have 1 for the maximum, 0 for the lowest value. So at least let's see how the inverted version looks like. Like I want to have, not sure though what I want, right? Like steeper edges in a way. And that's not good. It has to be multiplied and subtracted like this to still have the negative aspect. But like in the examples though, the examples 4D, 2D, 3D looks much different. And yeah, I don't know how to get the 4D version, for example. But I don't think it matters that much. I don't get it. How can we get something useful from this thing? Like, what does this... Oh, and I mean I have the light, which might affect stuff, right? But if I remove the light, I don't know, maybe it's gonna still look fine even without the light. Like this is gonna be really dark. Damn it. Let's keep the light, whatever. So, yeah, still some stuff that we need to do on the height map and resource map. But question is what exactly? So like, how does 4D version work? I mean, you know, we can use our own distance function, right? But I mean, Euclidean distance is fine. So because yeah, I mean I would have liked to have something like inverse maybe. Let's try it. Let's try to implement our own function or something. So it's gonna be inverse, and I think I want something like this, 1 divided by this kind of thing. I don't know how this is gonna look like, but inverse. Let's try to see how it's gonna look like. I mean, probably it's gonna have huge ass values, but yeah, not exactly like, okay, yeah, sure. Then I don't know how this works, right? But I mean, you still get like decent looking shapes, but question is how am I gonna merge the two things? Like that's the question, right? So I mean, you know, so I'll take a break and come back when I figure out how to do it. So yeah, small break. So I mean, I played a bit around with the values inside of here, and you know, we get something that looks promising in a way. Like it's a bit circly on this side, but yeah, like in a way, you know, it might look like a resource patch of some kind. But yeah, I mean, we still have to see. So I took this value from here. So let's imagine that we want to do like forest areas maybe. So we have t1 and t0, which is gonna be equal to this, and let's say if this is smaller or if it's the other way around, right? It's greater, we make it -1, which means nothing. So we would put forests like this, for example. But now I'm curious, how does this look like in combination with the map? Well, I'm not sure how we can show it. I mean, I can take this thing. Let's go to build terrain gradient, rainbow, what the fucking gay, noise map. Okay, so let's imagine that we have these two and we'll put them side by side to see. Hopefully it's gonna be kind of visible. So we have this thing, right? And let's say that we also have the thing with the tree. Like the trees. So it would be something like this for the trees, right? And like, you know, based only on this kind of area, right? No, I'm not sure about it. Like, I still feel like we should do some kind of division with this this thing, so we can get some kind of gradient rather than just white. Like, maybe we want some kind of gradient that would give us the probability, like density of trees. Let's say maybe in here it's gonna be higher density and on the edges it's gonna be lower density, something like that. Like, I would say, because you know, I mean, this is a resource patch, right? Sure, whatever, who cares? But we can spawn trees anywhere in here, for example. But also having some kind of density would be nice, like the probability of there actually being a tree, I want to say. So yeah, maybe that's what I want actually. So for that thing, right? So let's say, okay, if the terrain is between this and this, like if it's not inside of this range, then we don't care about the result from the calculation. But if we are between these ranges, I mean, let's say we make it 1 by default, right? So it's gonna be 1 by default. Not necessarily, right? It's gonna be 1 only if I think I have to say like smaller than this value, and otherwise let's say that I mean, I would say -1. So like, the fuck, I ran the other example. So this should add some kind of threshold, I wanted to say, but the fuck? Like, if it's smaller than the hell? Isn't this weird? If it's 1, it should be completely visible, am I wrong? Wait, what? Huh? Huh. Minecraft funny noises. So like this would be the hills on our map, right? Why didn't it like the fact that I put a 1? Probably it's, oh my god, it's strict comparisons. Oh well, that somehow sucks. I mean, no, if we are greater than, okay, let's do the other way around. So let's say, I mean, the same way I did before, I guess. So if we are greater than 0.5, we make it -1, and on the else case we just negate it, right? Just negate it. So this should still keep it as a cloudy color. Well, at least that's what I thought. Huh. You know, I'm curious if we increase back the frequency here, so we have more of them, how will that look like? So smaller patches, basically. I would say that smaller patches would make more sense for stone stuff, let's say, right? And bigger patches for trees. But I don't like the fact that it's just a square. So that's why I wanted to have some kind of probability instead of just that. So how can we make it cooler in this case? So I would like to switch the values from here. So let's say it's like this, right? So if we are outside of hills, we don't care about that value. Otherwise, if r is greater than negative 0.5, it means that the value is too small, and again we don't really care about it. Right, like we just erase it, minus one it. But if the value is smaller than negative 0.5, we want to negate it. So it's gonna become from 0.5 to 1, right? So 0.5, no, it's 0.5 to 1, am I right? It's from 0.5 to 1. After we negate it, obviously. So how about, so what can we do here? So we multiply this thing with minus 1. I would like to make it from, so I would have to subtract 0.5 and divide 0.5. Right, so subtract 0.5, this is gonna make it from 0 to 0.5, and then yeah, like multiply by 2, or so this should make it like a gradient. The fuck, like, huh, it's not gradient enough for some reason. What the hell? Can I print a line in here, the value of r? I'm just curious, what values are we gonna see? Because it's, yeah, right, it's between minus, I don't see anything greater than negative 0.5, so something's cooking in here. Maybe the amplitude is too small and it's too smooth, and then, but no, it's still kind of strange. Let's make it terrain gradient, because that has more points, and I'm curious how it's gonna look like if it's gonna have those smoother gradients. See, like it has this humongous white patch, which I kind of hate. So, I mean, if we don't do this, just to take a look at how it looks like. Yeah, it's like too... But it becomes even worse when using this. So let's say we don't do anything there. It's still like decent gradient, see? But the second we invert it, it turns to shit. How is that possible? Am I not doing it right with how I invert it? Is it somehow wrong? Like you have to just multiply with -1, am I right? Okay, apparently I'm wrong. What the fuck? See, like it becomes... But why is a good question. Am I stupid? Isn't this how you... So let's say we have, you know, numbers between -1 and -0.5. If I... Well, yeah, because that's... I mean, that's just how the gradient works. So maybe if we do rainbow gradient, we'll see it better. I mean, it looks a bit better, right? Okay, I mean, yeah, it means it's just the gradient who's a bit scuffed. Like this rainbowish gradient looks better. But yeah, right, like we have these circles. Yeah, I don't know if I want them to be circles or I just want to make it completely white. Right, this is also an option. Just make it completely white, and that's that. And this is the... Oh, but I cannot do completely white because... Yeah. Yeah, I mean... No, but I'm still... still a bit... It still feels a bit scuffy how the gradient looks like this when it's negative, and it literally turns to absolute complete garbage when it's the other way around. Like it's what? Yeah, that's actually, yeah, that's interesting, because with the rainbow was looking decent, this just turns white. the hell? I mean, you know, I trust too much the gradient implementation, so probably shouldn't do that. So yeah, it is what it is, whatever. So we could have values between -1 and 1 like this, and I would say, you know, this is how we might want to do like stone patches and stuff. Maybe have even bigger frequency in a way, although this is gonna turn everything to circles and I don't really like that. I mean, this is too small for the image, the frequency. So yeah, I mean, maybe we can have this like this. This would allow for better shapes rather than just circles, you know. But again, this may be like a good forest thing, maybe. Yeah, like this would look better on a forest, right? Or something like that. And like maybe even like this for a forest. Like we don't need the shading. So, no, I mean, yeah, I still have to play. Forgot again about the. But you know, I can use 0.5. Like, it doesn't matter. I only use 1 when it's in my code. So, and I don't depend on the shader, on the thing. But yeah, like this could be for a forest. But yeah, I still have to play around with this thing and actually spawn some stuff on it, right? And figure out which would be the best mapping for each kind of resource. So I guess, you know, in the next one I'll try to like thinking about it, probably splitting that noise into a grid and spawning trees like that would make sense. So yeah, like maybe even combining the two algorithms that we did today, the one with the circles and this one that like this generates the base. So in this area we can add, like in this white area we can add stuff, and with the other algorithm we would say, okay, so the other algorithm is the one with resources, and with the other algorithm, you know, we generate where to place them. So I guess, you know, that's all for today.